The funny elephant toothpaste reaction, presented by Tim Lyons. More foam! Last week we saw how the acid-base reaction of vinegar and baking soda produces a cool, effervescent, bubbling mixture that's powerful enough to fire a rocket. Today I'm going to show you a decomposition reaction that sends a warm stream of foam shooting out of its container. Welcome to the funny elephant toothpaste reaction. Here are the supplies we're going to need. Hydrogen peroxide, 10%. If you look closely, you will see, unfortunately, I have 3% hydrogen peroxide, which will account for some of the results that we see. The experiment still works, but trust me, 10% hydrogen peroxide would work better. Dish soap, food coloring, baker's yeast, warm water, and a tall, narrow container. You'll see I've used a votive candle jar. I think that something even with an even narrower opening would help to create a better foaming reaction. But not more foam, but it might project the foam faster and higher. Here are the steps. 1, pour 1 cup of hydrogen peroxide into whatever container you have, whatever your beaker is. Then add 4 drops of dish soap. Add some food coloring, you can use any color. And then in a separate container, mix 1 tablespoon of baker's yeast with 1/4 cup of warm water. And when you're ready, pour the yeast solution into the hydrogen peroxide solution and watch the foam pour out. So let's take a look at my reaction. You see, we're pouring the yeast into the hydrogen peroxide, and here comes the foam. And it's not quite shooting over the side, but there is a lot of foam. It continued pouring out for a good 30 to 60 seconds, filling a lot of that pan down below. The foam does get higher and higher, and it's warm foam. You'll see my son puts his hand over the top of it to feel the temperature of it. There's definitely heat being produced in the reaction. So that was our reaction. Oops. One moment, technical challenge. So let's talk about what just happened. Getting to know hydrogen peroxide. Hydrogen peroxide is H2O2. It's a pale blue clear liquid, slightly more viscous than water. It's used as an oxidizer, bleaching agent, and antiseptic. It is the simplest peroxide, which is a compound containing 2 oxygen atoms bonded together. Hydrogen peroxide is also a toxic byproduct of aerobic metabolism. Every aerobic organism produces hydrogen peroxide. To protect themselves against it, because it's toxic to them, aerobic organisms produce the enzyme catalase, which causes hydrogen peroxide to decompose into water and oxygen. And this is in the presence of catalase, this is a spontaneous reaction that increases the entropy of entropy. So hydrogen, an aqueous solution is being turned into a gas. When this reaction takes place, oxygen escapes the water via effervescence. This is the telltale sign of catalase. That is one of the ways that biologists this is the telltale sign of catalase. And it's one of the ways that biologists can identify aerobic bacteria. What you see here on the right is a catalase test. So the liquid in the beakers and the liquid on the slides is hydrogen peroxide. That hydrogen peroxide has been dripped onto slides that contain a bacteria sample, and the stick that's being lowered into the beakers also contains some sort of a bacteria sample. you can see up above when the sample begins to foam in the presence of hydrogen peroxide, there's clearly catalase in it, so that's an aerobic organism. And in the slide below it, where there's no foaming, that is a negative catalase test, and it shows that this is an anaerobic organism. Same thing on the right-hand side. The left beaker shows no foaming. The right beaker shows foaming or bubbles. So what's this have to do with our elephant toothpaste experiment? Yeast is a microscopic fungus and a facultative anaerobe. Now I know facultative anaerobe does not sound like an aerobic organism that I just described, but a facultative anaerobe is an organism that prefers to use oxygen. It prefers to use aerobic metabolism, but in the absence of oxygen, it can still function anaerobically. So for our purposes here, it is an aerobic organism, and the yeast uses oxygen for respiration whenever it can. Therefore, it has catalase in it, and that is what is causing the reaction that we're seeing. In a nutshell, it works like this. Yeast has catalase in it. The catalase catalyzes hydrogen peroxide decomposition, right? Makes it happen faster. So our hydrogen peroxide produces water, oxygen, and heat. The escaping oxygen bubbles get coated in soap, and then warm, soapy oxygen foam is ejected from the container. In closing, what we just observed is a spontaneous exothermic reaction that decomposes hydrogen peroxide, creating thereby greater entropy, in order to do the work of making foam.